We have heard 4 presentations today. One from Andrew talking a little bit about how he's thinking about space and how he's thinking about melanin. We've heard about Kat designing materials, maybe perhaps lighter materials for applications which could potentially be for radiation protection. We've had Radhamaz thinking about how do we scale up melanin production, which you saw is quite a challenging task in itself. He's trying hard to get those few kilograms there. And Fernando is thinking about how to actually construct things which will be reactive to radiation and perhaps be adaptive in changing the environment as we expose to radiation. So we've had some pretty diverse topics, and that was the goal of our theme here, is to expose you to different viewpoints about melanin. And I think this would be great if you can actually be more interactive. We can hear from you as part of some questions that you may have. And then if we can, then we'll try to do is open up this discussion in a more of a panel discussion and ask the panelists here to elaborate either your questions or some of the things that we'll bring up during our panel discussion here. So any questions from the audience?
Are they on? Craig. Oh, there we go. We have microphones. Anybody have a question?
I think there's Peter, hand up there.
I'll wait. Peter sides.
And they re-out might have questions.
Does it work?
Yes,
Can you hear me?
absolutely.
This is a simple one, I think, softball question. So the idea of biomimicry is getting a look at the biological system, learning how it works, and then translating that into the various ways you guys have been talking about. I'm also thinking at another level, do we know something about how the chemistry of melanin would allow us to build our own molecules that do the same thing, which could also be a parallel path for creating the tools to do all the things you're talking about besides just producing melanin through bioreactors, et cetera. Does that make sense, what I'm asking? I'm just wondering what you guys know about that and how it relates to the work you're doing.
Sure. Who wants to start? You want to say something?
I'll try and take a stab at it. I think if I get what you're trying to say is, what we have talked about here is primarily organic sources, naturally occurring sources of melanin. Melanin can also be produced synthetically, and maybe that synthetic approach allows tailoring specific properties of melanin for one application or another. So that's kind of one of my thoughts. And our focus here, we've heard a lot about radiation, but melanin is we talk about multifaceted. It's almost like a Swiss Army knife of a material. Whatever you need it to do, it does it well. And we see that it appears in the fossil record after a reversal of the magnetic poles. And when those reversals occurred, radiation on Earth was much higher than it is today. And nature, we heard from Don, who did a terrific job. Nature, through its own research and 4.5 billion years worth of evolution, came up with this material that we cannot manufacture physically. There is no man-made material that meets the same sort of properties, or has all the sort of properties that natural melanin has. Nature came up with that to allow life to survive here on Earth. And we know that that's true because prior to those magnetic role reversals, melanin doesn't exist in the fossil record. It shows up after a magnetic pole reversal. But I think if I got what and I'm going to turn it over to the other folks, I think what you're saying is a synthetic approach maybe allows tailoring for specific applications.
Peter?
There are efforts to produce melanin synthetically. There is a synthetic version available in the market. However, it's not the same as the natural melanin. There are some similarities, but there's also some differences. The melanin macromolecule, the melanin polymer, is huge. It's extremely complex we don't understand the structure of it. It's amorphous. So we have an idea of the melanin structure at the molecular level, maybe analogous to the primary structure of a molecule, but at the secondary, tertiary, quaternary level of dimension, we have no clue. It's just we don't have the techniques available to study amorphous molecules like wood. We don't know the structure of wood, believe it or not. So it is. It's a complex. The natural form of melanin is really complex. There are efforts to start synthetic approaches to it. Yes.
Okay. Thank you. Question? Wait for the microphone here. And there are two more. One is there.
Just how does melanin work as a sensor or in electronics? I didn't understand that bit of it.
How does melanin
Work as a sensor or in electronics?
So melanin is a semiconductor. It has both ionic and electronic conductive properties. In terms of the sensor, I'm not aware of any sensor that has been developed already using melanin, but there are properties that have been described already that show that if you, for instance, manipulate the amount of water associated with melanin, its electrical properties changes. If you irradiate melanin, its electrical properties changes. If you bind different components, inorganic compounds to melanin, also they change, like metals and stuff. So it is a biomolecule that responds to certain stimuli, and it responds electronically. So there is this idea, but I think there's these ideas and the knowledge, but we have to apply those. Still.
One at the back, Matt.
Hi, yeah. I was wondering, someone else described melanin as kind of a Swiss Army knife that does a lot of things pretty well. But I didn't see much, is there a good case study that shows that melanin can really outperform something that we already have? I mean, like radiation protection, does it perform as well as lead? Or, is there something where, is there something where it really outperforms what we currently have now?
Thank you.
Yeah.
You want to say?
Oh, I love that to answer that one. Yes, so that's a great question, right? So we know all these great properties of melanin, but how does it perform compared to the what is out there in the environment, in the market? There's very few studies available, and it's partially because melanin is so expensive to produce, and a lot of these experiments takes a lot of material to do. We have been working on this in the laboratory to look at how melanin shields against X-rays, for instance, and in its natural form, it has some capacities, but we can actually modify it to make it even better. We are working on that right now. But that's a great question.
Yeah, and I would say to add that we're not trying to replace like concrete, or in the case of, I think of like solar cells, like silicon solar cells is like mass on market. What we're trying to do is add an alternative method that it's more accessible, even maybe more affordable than some of the other methods that you can produce in like other locations or extreme locations that you can due to other more mass-produced already materials.
There's one question.
Thank you. So my perspective is as a neuropathologist studying Parkinson's disease, neuromelanin, and your comment, your picture, Radames, of the frogs, because there was a study years ago that demonstrated that melanin in frogs was affected by pesticides. It was an epidemiological study of frogs, and it related to the concerns that that Parkinson's disease actually may be an industrial disease, that exposure to pesticides or other industrial products might relate to the distribution of Parkinson's disease. So in the spirit of a Swiss Army scalpel, what do you think the role of melanin might be in this domain of human disease and understanding why melanin goes away in the substantia nigra?
If I may, and I was meant to bring it up in my presentation. Neuromelanin exists in a small area of the brain, close to the brainstem, called the substantia nigra, and it's basically its function is more like a security guard. It protects the brain from harmful radicals from getting into the brain and crossing the blood-brain barrier. One of the things that has, as you notice, or you made comment in, is they don't know exactly what the substantia nigra does, at least, and I am not a physician or a medical professional, so I'm kind of talking off the cuff here, but they have noticed that when there is a change in the melanin structure of the substantia nigra, it's coincides with Parkinson's. And one of the things that, not necessarily with Parkinson's, but humans did not evolve with indoor plumbing. And and so we've heard a lot over the years about lead in our water. But yet we know that calcium is important for strong bones and teeth. And so we have evolved to basically allow calcium in our bodies, but not lead. However, lead ions basically masquerade as calcium and are able to cross the blood-brain barrier. So when we talk about pipes or water systems where there is lead in the water, that's, it basically fools our body and allows those lead ions to get into our brain, which is why it's so harmful for us. I personally think that is, at least, it's definitely unhealthy, but and I don't know exactly what, the relationship is. You talk about an environmental cause of Parkinson's. That's an interesting thought, but I know that there is a relationship to a change of the substantia nigra and onset of Parkinson's.
Okay, it's a question for you. There is a question from online.
Yes. So there's a question. In nature, there are a number of species which are texturizing their surfaces to increase melanin absorption. Do you think such nanostructures can be developed on the artificially developed melanin-rich foils to enhance the absorption?
I want to say something more, but you've been thinking about this problem a little bit in terms of how to increase melanin production.
Can you repeat things then?
Yeah. So in nature, there are a number of species which are texturizing their surfaces to increase melanin absorption. Do you think such nanostructures can be developed on the artificially developed melanin-rich foils to enhance the absorption?
No.
Very well. So what I understand about the question is that, yes, in fact, many organisms in nature use melanin in their intergumentary system, like us, not only to protect their cells from radiation, but also to capture heat. That's the way they warm up. The phenomenon is called thermal melanism, and it's observed in animals, plants, and recently fungi as well. In fact, a lot of black fungal species like to live in the poles at high latitudes, like Andrew mentioned, in Antarctica and the Arctic. So yes, nature already uses melanin to increase their temperature of their surfaces. So yes, we have also used that as inspiration to create melanin coatings and using melanin to also increase the temperature of surfaces. And over there in that realm, we think that melanin has interesting applications in solar thermal technologies, right? Instead of using those metal-based toxic compounds to absorb electromagnetic radiation, we could use an organic material like melanin that is non-toxic, and it also absorbs a lot.
And if I understood well, there are not just these living organs, the radiotrophic fungi or the black mold that produces melanin. As we have discussed before, there are others that have this phenomenon as well. No? I don't know if the question is going on that.
I think good. Thank you. I think there's one more online question, right?
Yes. So there's a question about radiation. how much radiation can melanin block before becoming ineffective? And then does it wear out and lose its radioprotective properties after being exposed to enough radioactivity?
It's a big question. Should I? So in terms of UV rays, melanin is really good at blocking, and it's really, really stable. Other types of radiation. So basically, the answer to the overall question is that we don't know. We don't know how much. For these questions, we don't know the answers of, and we're working towards them. It's funny because a lot of the questions, the answer is the same. It's from what is neuromelanin doing? We don't know that much. Synthetic forms of melanin, we don't know the structure of melanin. Sensing. So there's a lot of research and development that needs to happen, and in particularly the radiation aspect. There are studies, though, by Kate Dadashova, which has been mentioned a couple of times already, that she basically looked at the structure of melanin after being bombarded with a lot of radiation. And there is some degradation, some breakage, some suffering, some sacrificial aspects, if you may, that happens in the melanin that does not happen in translating to the fungal. So it's like melanin acting as a shield, and it does get damaged. But she also demonstrated in that study that the melanin gets restructured and rearranged as well. So recovers. So there's some indication that it does recovers after being radiated, so which I think is really interesting.
And also we know, I think, in the 90s when Sadanova took the samples to her lab, she saw how the fungi was approaching to the radioactivity, but we don't know what is happening with that radioactivity if actually it's being reduced. I mean, I would love to know that, because in my case, for example, the prototypes that I'm trying to do will be completely solved with the solution. But I'm excited also to know that.
Thank you.
So let me add on to, if you think about research in general or technology development, the vast majority of things that we enjoy in life and we take for granted today have been in development, the light bulb, since the 1800s. There's been a century of development to get us to the point where we now enjoy halogens, LEDs, so forth. And we take that for granted. Right now, melanin is right about 1900, 1910, as far as where we're at in development. The answer to most of our questions is we don't know. There's a ton of work that has to be done, but we can see, if we look to the future, we did this little exercise yesterday, what would we tell ourselves in 50 years? There is a ton of potential here, a ton of applications. All of them are excellent.
Okay.
Will you take one more?
So, similar question, but we maybe take one last one. Okay, right there.
Hi, I'm a student from Laurel School's Environmental Justice semester, and I noticed a lot of your projects involve advancement in outer space. So how do you see these endeavors affecting sustainability and environmental justice on Earth? And is considering the ethics in space development a factor of your projects?
Who wants to address this question?
I can talk a little bit about it. So my project straddles between space and terrestrial. Some of the work that I also do is, again, sort of being able, so the microcomposite work, which is not necessarily the melanin, is a way to use waste materials and add that as a way to create building structures, so without using concrete or things. And Chris Maurer is like one of the leading architects in doing that. And so one of the things that I personally, because I'm always thinking about sort of how this will affect the people and the consumers, my thoughts behind it is what would be useful to, what's what I'm looking for, to cleaning up the world in a way, and doing some of these, the microcomposite work and also the aerogel work with the insulation is replacing plastic on Earth, replacing some of those polymers, those toxic chemical materials, doing something that's more safer for humans and also biodegradable. And that's sort of my thought process on the Earth. So that's like the second part of your question.
If I can, this is our final thing. If we fast. Yes, my takeaway message: melanin doesn't exist without life. Life doesn't exist without melanin.
That's a good way to end. Good way to end. Thank you.